Hello and welcome to today's GFG problem. The day uploading extremely well. So let's see today's problem: maximum product subarray. What the problem is saying is we'll be given an array which contains positive and negative integers. Okay, and also the array may contain zero as well. We want to find the maximum product that we can get in a sub array of air. Okay. So first of all, let's quickly see what is a sub array, right? So you may be knowing what is a sub array. Sub array is nothing but a contiguous set of elements. Okay. So the subset of contiguous set of elements. For example, this can be a sub array -2, right? Or this can be a subarray. So the elements are together basically, or this can be a subarray, right? Or the complete array can be a subarray. Okay. But what is not a subarray? So -2 and -3, they're not subarray because they're not contiguous, right? So that's what the problem is saying is we want to find out the maximum product, okay, of a given subarray. So here in this example, what is that? What is that maximum product? Okay. So this is a particular subarray which gives a maximum uh, which gives the maximum. So what it is? -30, right? 30. Sorry. Yeah. So what it is giving? So it is giving 180, right? 30 into 6. It is giving us 180. And if you see, if you can go through and you find out that this will be the maximum, this will be the maximum product, okay, of this particular subarray. Okay. So this is the ask. Okay. So we want to find out the subarray which gives a maximum product. Okay. Okay, so let's quickly now see the approaches, right? How we can solve this problem. So now since it is a sub-array problem, so what is the naive approach which comes to mind, right? The two follows, right? Int I equal to 0 to n, right? Other follow will be j equal to I. Whenever you want to have whenever you want to iterate through all the possible subarrays, and if the expected time complexity is O of n square, then this is the approach, right? This with this two follows, right? You're going to you can basically iterate through all the subarrays. So for example, I is here, right? This outer follow, and there's this inner follow, right? Where j starts with I, right? So now j will keep on going. So j will keep on going, right? J, for example, j is here, then j will be here. J, like it, we will keep on iterating till the end. Then again, when I is incremented, right? When I is incremented, I comes here, then j starts from here. Again, j will be here. So in this way, j will iterate to all the possible subarrays, right? And like, what will be the pseudocode for this? Product equal to 1, right? And what we can do is product equal to product into air of I, right? And all the time after this product is calculated, we can have a max product, right? Max product, and we can initialize with minus infinity, like minus infinity in the sense it is integer or mean value. And we can again check max product. We can compare max, right? We can compare max product with max, and whichever is the maximum, we'll assign back to max product, right? So in this way, it will solve a problem. But here the time complexity it is going to O of n square. It is going to take O of n square. Now let's quickly see the optimal approach, right? How can we solve this in a better time complexity? Yes, definitely we can solve this in a better time complexity. So let's see how we can solve, right? It's all observational basically. It's all observational. Okay. So here, okay. So let's quickly see, right? So there are various scenarios, right? There are various scenarios. For example, if for example, let's take this, right? -2, 6, or for example, let's take first example, 2, 6, 3, and 4. If such is a subarray wherein all the elements are positive, all the elements are positive, that is the first case. All elements positive, right? In this case, the maximum product will be the product of all the elements of this array, basically, of all the products of all the product of the array elements, basically. Okay, so if all the elements are positive, then the maximum product will be to multiply all the elements, basically. Okay, then second approach would be what? Even number of negative elements, right? If this is the case, again, -2, -6, 3, and 4. So there are even number of negative elements, right? -2 and -6. So in this case also, the product of complete array will give you the maximum product, and that's what we want to return. Again, because -2 into -2, it will give plus only, right? It is as good as all the elements being positive. Okay, so this is the second step. Now, third step, third, what we'll say scenario is what we'll say odd number of ones, odd number of negative elements, right? Odd number of negative elements, right? So, for example, if this is the case, -2, 6, -3, 1, -10, and 5. So in this case, you can see there are three negative elements. Okay, there are three negative elements. So if you take the product of all the elements, then definitely it is going to give negative because there are odd number of negative elements, right? So it is going to give a negative, which won't solve a problem, right? Which will solve a problem. So how can we solve this problem? How can we solve this problem? So if we, for example, so if there's this negative element, if we ignore this element, right? So the maximum product can be either from this subarray or from this subarray. Okay, from this subarray. For example, here this the product will be what? -12, and here it is going to be what? Here it is going to be -50. So which is the greater one out of this one? This is the greater, right? This is the greater. This is the greater product. -12 is greater than -50. Okay. Or other thing is what you can do is you can ignore this one. So in this case, either the max product will be what? 5 or this one, this particular subarray, right? You can check. -2 into 6 will give us -12, -12 into -3. -12 into -3 will give us what? 36. 36, right? And here it is 5, right? So 36 is the maximum out of this, out of which subarrays, which two subarrays? This and this particular subarrays, right? Or the other approaches, the other, so we can also ignore this particular element, right? And there will be this particular subarray, right? This particular subarray, and now you can calculate. So 6 into -3 will give us what? 18. -18 into -10 will give us 180, right? 180 into 5, it will give us 900. 900. So here till now 900 is a maximum, and hence the maximum product will be this from this particular subarray, from this particular subarray. So what we want to do is, if there are negative elements, right? Any in any case, right? So what we can do is you just saw, right? So what it is, for example, if we are ignoring this particular negative element, right? So we have two options here, either this subarray or this subarray. So what is this? This is prefix subarray, we can say, and this is suffix subarray, we can say. Okay, so we'll calculate the prefix product, right? The prefix product and suffix product basically, and we, for each negative element we are going to do that. Okay, okay. So here with this we saw that if we ignore this particular, then we get the maximum, which is 900, and that's what we're going to return. Okay, we'll dry run. Okay, we'll dry run this approach. The fourth one is what? uh, array containing zero element, zero element, zero element, right? Array containing zero element. So for example, again, the same approach we are going to take. For example, this is the 7, 9, right? So if if there is a zero, right? If there is a zero in an array, so let the numbers be like, the numbers can be big basically, right? The numbers can be big, but multiplying with zero, it is going to give us zero only, right? Right, into zero only. So in this case also we'll have to ignore the zero, and we'll have to calculate. We'll have again two options: prefix subarray and this suffix one, right? And we have to take the maximum out of these two. So here it will give -12. 9 into 7, it is going to give 54, and we have to compare the suffix and prefix product, and whatever is the maximum, we have to return that. Okay. So in this case, again, we have to, as I said, for zero also, we have to ignore that, and we have to calculate the prefix and suffix. Okay. So this is we are going to use, right? This approach we are going to use to solve this problem. Okay. And this will give us what? This is going to give us uh, time complexity of O of n. We'll see how it gives O of n. Okay. So I've already explained. Let's now dry run. Okay. Let's now dry run. So here, if we come here, right? So what we're going to do is we're going to have a prefix variable. Okay, let me write here prefix variable 1 and suffix 1, right? Suffix 1. So what we're going to do is we're going to start from here. Okay, I will be here. Okay, now let me also write the pseudocode. So what the pseudocode will look like? Int I equal to 0 to n. Okay. So here, what we're going to have? Prefix equal to 1, suffix equal to 1, right? Suffix equal to 1. Okay. So, so what are we going to do? So prefix, let me write here. So prefix equal to prefix into array of I, right? And let me write suffix equal to suffix into array of n minus I minus 1. So why? Let's quickly see. So here, so suffix will start from here, as you know, and prefix will start from here. Okay, so what are we going to do? So for example, I is pointing here, right? I is pointing here. So in that case, what are we going to do? So 1 into array of I. 1 into array of I will give us what? Array of I is -2. So 1 into -2 will give us -2. So we'll update a prefix. Okay. And here, the suffix will be here. How it is here? So according to this formula, so what will array of n minus I? N is what? 1, 2, 3, 4, 5, 6. 6 elements are there. 6 minus I is 0 minus 1, which will give array of 5. Right? Array of 5. So R suffix will be here. So what are we going to do? 1 into 2, which will give us 1 into 2, which will give us 2, basically 2. And what we'll have? We'll have a max product as well, right? Which will initialize with minus infinity. And then we're going to compare this, and this, whichever is maximum, right? Whichever is maximum. So 2 is maximum in this case, right? So we'll update and we'll assign it to max product, which will be 2. Now we'll go ahead here. We'll go ahead here. Our I is here now. So we are going to what? We are going to multiply -2, the prefix with this array of I, right? Which will give us -12. Similarly here, it will give us what? Suffix into this 0, right? So 2 into 0 will give us 0 only. Will give us 0. Now again, we're going to compare this, and this. So 2 is maximum. So we will keep it unchanged. Max product will keep it unchanged. Okay. Now again, we proceed ahead. So we are going to first check here. Now we are going to check here. Here, for example, if prefix equal to 0 or suffix equal to 0, in that case, we are going to assign prefix 1. For example, these are going to be separate cases, okay, separate conditions. If prefix equal to 0, then prefix 1 will initialize, and suffix 1 if suffix was 0, right? If suffix was 0. So why? Because we are resetting, we are ignoring this particular 0. We are ignoring this particular 0 as I've already explained, right? So it is going to be 1 now. Okay, it is going to be 1 now. Now our I is pointing here. So 12 -12 into -3 will give us 36, right? And with this, our suffix will be pointing here, okay, which will give us what? 1 into -10 will give us -10. Okay, 1 into -10 will give -10. Now we're going to compare all the three. 36 minus 10 and 2. So now 36 bigger, so we'll update a max product to 36. Okay. Okay. Now we'll again increment our I, right? Increment our I. So now prefix into array of I will do, right? 36 into -10 will give us -360, right? And a suffix will be here. If you calculate, right? What is I here? 0, 1, 2, 3, 3, right? 0, 1, 2, 3, right? So if you do array of 6 minus I, 3 minus 1 will give us 2, array of 2, array of 2. So what is array of 2? Array of 2 is here. So J will be pointing here. So what we'll do? Whatever is the suffix value into array of n minus I will going to do. So -10 into -3 will give us 30. Okay. Now we're going to check here whichever is maximum. So here max product is already having greater element. So we'll keep it unchanged. Okay. Now we'll proceed ahead. Our I will be pointing here. Our J will come here. Okay. You can consider array of n minus I minus 1 as the J, right? And then again, now this I is array of I is 0, right? So this -360 into 0 will give us 0, right? And then our array of n minus I points here, right? So 13 to 6 will give us 180. Now we'll compare 0, 180 and 36. 180 is greater, so we'll update 180. Okay. Then we'll go to the next element. I is pointing here. So our prefix is 0 now. According to this particular condition, we'll initialize with 1. Okay, we'll initialize with 1. 1 into 2, right? Array of I will give us 2, right? Will give us 2. And this will, our J, array of n minus I minus 1 will point here, which will 180 minus 180 into 2 into -2 will give us -360. Now we'll compare 2 minus 360 and 180. So 180 is bigger. So we'll keep max product as unchanged. And this will be our answer. Okay. I hope you have got the intuition behind solving the problem. I think you'll understand better before when we implement the code. Okay. So just one request before going to the code, I'll request you to please subscribe to the channel, like the video. Okay. If you understood the solution, let's quickly code. Now as per our pseudo code, right? So we'll have prefix and suffix equal to 1. Then what else? We're going to have a max product, which will initialize with integer dot min value. Okay. Then int I equal to 0, I less than n plus plus I. So first I'll show the Java code followed by C++. Okay. Again, not much difference between the Java and C++ code. Okay. So let's write. So here, what are we going to do? Prefix equal to prefix into arr of I, right? Suffix equal to suffix into arr of n minus I minus 1, right? Here. Now we're going to check here max product. I've already explained this. Max product equal to math.max max product. Max product, right? Again, math.max, as I've already told, that we have to compare all the three, right? And which is maximum, we have to send back to max product. Okay. Prefix and suffix. Also, we want to add two more conditions here. If by chance if prefix becomes 0, then we have to initialize it back to 1, right? Because otherwise a prefix product for the next subarray, right? Starting after 0, it will be 0 only. That is why we have to reset it to 1. Similarly, suffix also we want to do suffix. Okay, so I think we are mostly done here. Let me return max product. Okay, let's compile this. Let me submit. I hope you have got the solution. So this will take what? O of n time complexity, okay? And O of 1 space complexity. Okay, so please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code. There'll be slight changes also. I'll add the code in the comment section or in the description. So here we have already implemented, right? So prefix 1, suffix 1, only this integer min we are assigning, initializing max product integer min, right? Rest everything is same. Only this we are taking max function from the standard namespace. Okay. So thanks for watching. Please don't forget to subscribe to the channel, like the video. Have a happy, healthy, and a great day. Thank you so much.